to Western countries to make so little money, right? Yeah, just like Apple. If you Google it, for each device, on average, how much percent of profit Apple makes it? I guess around, to my memory, 80%. Okay? And how much TSMC makes? Some years ago, 9%. I guess nowadays more than that, because the chips becomes more expensive than before. Okay, but you can see TSMC may make more than 10, more than 15%. That's it. Okay, and how about Apple? I think it still make more than 70% of the overall profit. And the company helped Apple to assembly iPhones, iPads. How much percent they make? I guess 3 to 4%. Okay, and they need to support millions of workers. Wow, it doesn't make any sense. You need to support so many workers, but you only make very few percentage of the benefit, of the profit. And Apple, it only focuses on design. It doesn't fabricate anything by itself. Never mention about the chips. No, everything, the camera, the memory, everything, it wouldn't like to touch. It only focuses on design. And then it can make the most profit. All right? Maybe Apple is a good model for Indonesia. If you would like to go for IC fabrication, sorry, tons of money again. All right, let's go back to the future. Taiwanese government would like to change our industry, okay, to get more technology, okay, and to increase the percentage of the profit we can make, blah, blah, blah. So from the very beginning, our governors had no idea which way to go. So they are humble. They try to invite somebody for help. Luckily enough, we found this guy, Pan Wenyuan, Mr. Pan. In that era, he was some kind of a manager or something for RCA. Yeah, some kind of bad company. Yeah, anyway, it polluted our land very much. Anyway, yeah, forget about it. To his own goodness, to the goodness of his own company and his mother country, he thought a lot, and then he accepted our invitation and quitted the job from RCA. From the beginning, his wife against it very much because our government, Taiwan was so poor in that era. It is already, you can see, 1976. Okay, almost 5 decades ago. Yeah, we are really, really poor. Maybe Philippines in that era was better than Taiwan. We have many kind of Taiwanese try to work for Filipino in that era. Yeah, 1 peso equivalent to almost 40 Taiwanese dollars. Okay, and how about right now? 1 peso equivalent to only 0.7. Okay, that is another story you guys can learn. If you choose the right way, you can do something like Taiwan. If you choose the wrong way, for example, IC fabrication, okay, you may face the same consequence as Filipino. Hopefully not. Okay. Anyway, he sacrificed a lot because he needed to fly from USA to Taiwan and vice versa for many times. Anyway, our governor listened to him and he recommended Taiwan to go for IC, go for semiconductor industry. In that era, all the companies were IDM. It means what? They designed and fabricated all the chips. Okay, so we sent a group of young engineers, more than 20, to RCA to learn everything. Okay, so they simply watch carefully to measure how long for each step, and then how much temperature, how much pressure, blah, blah, blah. Anyway, but again, there's no promise to succeed, right? So for those young guys in the first autumn festival, Mooncake Festival, I will come in soon, right? The 20-something young Taiwanese, they drank in Silicon Valley, looked at the same moon as their families in Taiwan. All of them hugged together to cry. Not only for themselves, but also for Taiwan, because we pour a lot of money to support them. They worry a lot. They worry a lot. They never knew whether we would be successful or not. They worried a lot. Okay, but luckily enough, we made it. Okay, luckily enough. So you can see, after 1 year, we had some kind of demo site in E3. Oh, what is E3? Actually, it looks like LIPI here. But LIPI focused on both science and technology, right? We separated science for Seneca and technology for E3. That is the difference. Okay, so we had such kind of demo site, actually copied and pasted from RCA. Everything we bought the fabrication knife because RCA would like to phase out all those fabrication knives. So we bought it. We learned it, we bought it from RCA. And the price, I think, is supposed to be quite nice. Okay, anyway, anyhow, yeah. After we constructing such kind of demo site, you can see the yield was improved from 17% to 70%. Wow. We need to pay much respect to those young guys. Okay? In RCA, it is only 17. But in Taiwan, 70. Tin and T means a lot of difference, right? That is the very beginning of our success in semiconductor industry. That is a promise. We Taiwanese work harder than American. Okay? You too, right? But sorry for that, the timing window was closed. Why? In that era, nobody thinks semiconductor is so important. Okay? Yeah, anyway. So you can see, one of the young guys, President Chao Xing-chen, yeah, he founded, under the strong support from our central government, he founded, or our government founded the first semiconductor company called M.Sc. It is still the top 2 in Taiwan right now. Okay? And then we would like to go further, so our government invited another even more important guy, Morris Chang, the godfather of Taiwanese semiconductor industry. Why? Because he was invited to be the chairperson of E3, right? I mentioned already. Morris Chang in that era was already the vice president of TI. And TI, to my memory, was the top 1 company. Till now, TI is still the top 1 for analog IC design around the globe. But it also design. In the past, also fabricated, but right now only designs analog chips. Okay, overall, it is not top 1, but top something. Yeah, better than top 10. Okay, Morris Chang in that era was already the vice president. But again, he would like to sacrifice. Okay, so how many in donation they would like to sacrifice? You need to count. Okay, yeah. So after that, he thought for quite a long time, 2 years. Okay, yeah, because we already had UMC Morris wouldn't like to be a copycat. He would like to create a brand new business model. So to the end, he insisted to go for fabrication only. Why only fabrication? Because you won't compete with your customers. Got it? Not like Samsung. Tens of years ago, not more than 10 years ago, Apple got help from Samsung to fabricate its own mobile phone chips, right? Samsung also designed its own. After they got the layout from Apple, they invite the design department to have a look, then stop their own design. They would like to announce it, but stop it. And after watching, and then copy and paste, blah, blah, blah. Okay, 3 months later, they announced their new chip. All right, and the performance was already better than Apple's chip. It doesn't make any sense, to be honest. Okay, it's really, really upset. Samsung did such kind of dirty business, even with Apple, the top one, the top one company on earth. So it was sued by Apple. After tens of years of suing each other, finally, Samsung needed to pay Apple for 10 billion. I'm talking about US dollars instead of rupiah or NT dollars, no. To most of the humankind on earth, they would think, wow, 10 billion US dollars is a big money. Sorry, piece of cake. Why? Because by copying and pasting Apple's design, I guess Samsung made more than 100 times of the benefit by stealing the secret of the others. So let's go back to Morris. From the very beginning, he wouldn't like to focus on design. No, he promised we only focus on fabrication. We don't steal anything from your design. We don't compete with you. Okay, till now, it is still the best on earth. Okay, that is a promise. So, Apple never goes to Samsung for fabrication. Okay? Anyway, you can see that is a brand new model, but nobody knew it before. So, Morris needed to go back America to please Intel. Oh, sorry. No. Don't bother us. We design and fabricate our own chip. Then he went back to TI, blah, 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 blah. Anyway, it's some kind of torture for Morris. But anyway, Morris would like to go further, unstoppable. So finally, he got some kind of fabrication, okay? And then especially from Philips. Philips was quite talented. Yeah, he invested a lot of money on TSMC. But to help itself, and also TSMC, he got TSMC for help to fabricate, to help TSMC stand on its own feet. Why? Because it also invested a lot of money. Okay, so that is some kind of win-win solution. Got it? Anyway, we made it through the help of many of the local international countries, and Philips is, I guess, the most among the globe. Yeah, anyway. So, yeah, till now, you can see we are top one in IC fabrication. In last year, we dominated the market for 60-something%. Okay, but in this year, the most updated information shows that only TSMC itself dominates the market for maybe 60%. 63, sorry. And we still have UMC, blah, blah, blah. So overall, I guess, in this year, we can make it to be 70%. But if you go back to the origin, we dominated 100% because nobody did such kind of business. And again, why? Because nobody paid attention to this market. Morris created, okay? Yeah. And how about right now? No. Everybody, every good countries have a look at, watch closely the semiconductor industry. And this is the reason why I told you, I recommend you, don't touch IC fabrication, okay? It may waste a lot of money of your country. So we are also top 2 in IC design. From the very beginning, we don't have any idea about how to design IC. Okay, so from the very beginning, our Ministry of Education sponsored a lot of money, even till now, to develop all the slides to teach our students. Okay, so we get money from Ministry of Education to compose, to prepare the slides, not only for ourselves but for all the other professors. Okay, we got money from MOE, and for the other professors to copy and paste our lecture notes, they also got money from Ministry of Education, and it makes a lot of sense. Okay, your country had better do something like this. Yeah, your Ministry of Education, Ministry of Industry, both had better pour money into semiconductor education instead of IC fabrication. No. Oh, don't tell the truth to your ministers. Maybe they will be angry. I'm only kidding. In this way, you can complete your own ecosystem for education and then go for IC design. All right, but anyway, at current moment, you don't have enough professors. I and my other Taiwanese professors, my other very good friends, all of us can help. Okay, hopefully, look into the future, we will become both top 1 and not only for IC fabrication, design, and everything. Actually, we are the top 1 in IC fabrication, packaging, and testing. Top 2 for IC design. Who is the top 1 for IC design? Of course, our big brother, America. But look into the future. Hopefully, we can also defeat our own big brother for IC design. Hopefully, and you guys here can copy and paste the same thing. Okay. That is what I can help. And this is what I would like to warn you. Don't touch IC fabrication. Why? The ecosystem is so complicated. Not only you spend money, you can make it. No. You cannot say, oh, if TSMC would like to come here, how much you need to pay? At least 50% of the construction fee. Okay, but even TSMC comes here, it still doesn't make any sense. Why? Because it needs a lot of the other companies to support, to complete the ecosystem for fabrication. The investment, I promise you, hundreds or even thousands of times more than only focusing on IC design. Believe it or not. Okay? Yeah, so we have everything from the upstream to downstream. Okay? What is the upmost stream for IC, for semiconductor industry? IC design. IC design houses. Then fabrication, and then packaging, testing, and finally to application. So Apple, in theory, is to the bottom of the ecosystem, to the downstream, but it also designs its own chip. Okay, so to the upper, to the most top and most bottom, and then it can make. Right now, I guess 70% of the profit. I guess. Okay, and semiconductor industry is so important that some Americans call it silicon shield to defend Taiwan from Chinese attack. Okay, yeah, so you can see, yeah, Taiwan island is totally fully covered by chips. In this way, yeah, America, right now not only America, Japan, yeah, they say, don't touch Taiwan. If you touch Taiwan, we will fight back for Taiwan. They highlighted already. And how about the European countries? Gradually, they change their attitude. Okay, they don't say we will be involved, but they want China, please don't touch Taiwan. Okay, so hopefully, look into the future. Most of our good friends will help us. At least stand at our side. Okay, this is a foundry market share. You can see, we dominate. That is in last year, right? But in this year, even TSMC itself can make it. All right, so maybe around 70%. Yeah, for the most updated information this year. Anyway, that is a slogan. Yeah, we joke. Taiwan #1. Why we joke this? Yeah, to make Chinese angry. If they chat online or play games online, right? If you would like to make Chinese furious, we just say this: Taiwan #1. Not only us, many of the Western guys, they highlight this. Then Chinese will become so angry, and to the end, lose all the game. That is that is some kind of dirty trick. Okay, and you can see the foundry market share TSMC is the top. That is for last year, not for this year. Okay, and then we have UMC. It's still top 3 globally. Oh no, top 4. Okay, anyway. Okay, and then go for this is also a Taiwanese company. So overall, I guess we can dominate the industry for IC fabrication for more than 70%, I guess. And for such kind of fabless IC design houses, fabless means what? They only design chips instead of fabricate the chips. Okay? Then who was the most Qualcomm for mobile chips? But that is only in last year. And you can see we have MediaTek, Novatek, Realtek. We have 3. Yeah, inside the top 10. Okay, within the top 10. And allow me to highlight this one. Yeah, Marvell. Okay, because one of the co-founders is said hard, blah, blah, blah. He's from Indonesia. He was born here. Okay, anyhow. Yeah, it's really fantastic. And this is also in last year. And you can see, MediaTek, number 5. Marvell, number 6. We are friends. We are brothers. See? So, allow me to show you unique key man. Right? And I only know its Chinese name, Zhou Xiuwen. Okay, but how about his Indonesian said hard, blah, blah, blah. Okay, that's it. That is the key man. Your government already know it. Your Minister of Industry flew to Silicon Valley to visit him, to ask him for recommendation. And what did he say? What did he say? Do you guys know? Any idea? The same. Don't touch IC fabrication. Focus on IC design. Okay? Even though many of you may not believe in me, but please believe in your own key man. Okay? Indonesia is his mother country. All right? Oh, so he flew frequently back here or to Singapore. Then your governors, professors will be able to reach him for help. Yeah. So let's look at the other country. That is Indian dream. You have a dream. We have dream, right? Indian also have dream. China has China dream, just like Xi Jinping. Okay. Putin also have dream. Yeah, anyway. Okay. Bad dream for everybody. Now you can see all those from Google, right? Microsoft, YouTube, Adobe, and even in last year, Twitter, okay? All those are from India. So it means what? India is softer we are harder. Many of them, most of them focus on software. And we Taiwanese, we focus very much on hardware. Okay? And this is the reason why we can be so successful in IC industry. We are harder. We are tougher. Anyway, I'm only kidding. Okay? Yeah. So even the Prime Minister, Modi, would like to invite TSMC, but TSMC say no, enough is enough. Okay, so Modi tried to find the other one, the president of Foxconn. Foxconn actually is a company to help Apple to assemble most of the iPhone, iPad, blah, blah, blah. And how much percentage the company made? I mentioned already, 3 to 4%. It doesn't make any sense. So Foxconn has a semiconductor dream. Modi also. And you can see they both are dancing in tango. Okay? And will they be successful? I doubt. Maybe for mature process, yes. For the chips applied to car industry, anyway, it is possible. Okay? But days ago, I saw some bad news for India, about its semiconductor dream. You can see the same recommendation from a very famous international journal called Economist. The Economist. Okay, what is their recommendation? Again, don't touch IC fabrication. Only focus on IC design. India is larger than Indonesia, right? If the economists think it doesn't make any sense for India to pour tons of money into IC fabrication, I guess they will provide you the same recommendation. Okay? Anyway, anyhow, we have Taiwanese new dream. Why? Because the CEO of NVIDIA, right now, NVIDIA is already the top one semiconductor company on earth, according to its AI GPU. Okay? And who helps NVIDIA to produce it? TSMC. And who is the CEO? He's from Taiwan. He was born in Taiwan. Okay? And Lisa Su, the president, the CEO of AMD, she was also born in Taiwan. Who? Taiwan. Actually, they are relatives. Wow, it's amazing. They are cousins, to my memory. Okay? Yeah. And who is this guy? He's a co-founder, CEO of Moderator. What is that? The top one image processing chip on Earth for many kind of drone, just like those installed in the drone to attack Ukraine and to fight back Russia. Most of the chip actually come from this company. But why I mention him? Because he's one of my classmates. Okay, so he can leverage our relationship. So I put him here. Okay, and this is Taiwanese new dream. You can see we are not only good at IC fabrication, right? Even for IC design, you can see some of the key persons on Earth are also come from Taiwan. So again, I need to highlight that we are harder than India. Okay, so we hope we can go further to become the top one, even in IC design. Okay, so that is Taiwanese new dream. So you can see months ago, you can see Intel, the top one. But sorry for that. All those, TSMC defeated all of them, all those two, and then, defeated by NVIDIA. Okay, so right now, if you have a look at the stock market, NVIDIA top one, TSMC top two, to my memory. Okay, Yeah, that is a few months ago. Yeah, the result is overturned already. Okay, so this is some kind of joke. According to humankind's evolution, we evolved from chimpanzee always stand up to hunt the animals. But according to the evolution of our semiconductor, humankind bend it down, right? But why I would like to encourage you to join us? Because we hope through the new development of semiconductor, we, humankind, can stand up again. Just like this. Okay? On the contrary, if we take away the chips from our society, what will happen? We are upset. Yeah. Go back to the Stone Age. Okay? All of us will become Flintstone somebody. Okay? Yeah. Anyway, hopefully it won't happen. All right. So do join us. Oh, this is my finally. Okay. Yeah. It's already almost 1 hour. Anyway, I need to highlight that I served as the associate editors for IEEE 2 journals, TV Systems and IEEE SS. Anyhow. And I'm the adjunct professor for ITB, then VIT India. Okay? And for UI, it's still under processing. And when I visit ITS days ago, right? Yeah, they would like to recruit me. Yeah, so it's about to process. Anyhow, yeah, that is why I always visit your country. Okay, I will show up again and again. Oh, but allow me to update my photo. Yeah, it never be true, right? Yeah, I'm no longer young. Sorry for that. So before my departure, days before my departure, I asked help from my son. Yeah, to take another photo. Not only to update, okay, to update this, but the main reason is to apply visa from India. To apply visa online, it said you need to carry the full responsibility. Don't use any kind of photo. Yeah, years ago. So I think, yeah, if I use this, maybe I will be stopped in India, right? So I had better to be an honest guy. Sorry for that. Anyhow. Okay, so you can see for the rest, I still would like to try my very best to convince you. Yeah. If you would like to teach students for IC design, especially for analog IC design, the most fundamental 2 classes should be analog IC design and analog IC layout, along with all the others, just like ADC, 1 semester, analog to digital converter. Okay? Phase lock loop and delay lock loop, another semester. Blah, 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 blah. So how many courses? A lot. All right? But we can help because we have many Taiwanese professors focusing on this field, okay? Including myself. So in my class, I would like to teach my students all necessary know-hows and backgrounds. For analog IC design, the most difficulty is what you see is never be what you get after fabrication. Never mind how hard, how good you try for your pre-simulation, post-simulation to the end after fabrication. Usually, my students or new young engineers, after they get the chip, measure the chips, they usually say, wow, well, what? So good. No, sorry for that. It's really bad. Or even many of them, maybe more than 50%, are malfunctional or they don't work at all. Okay? So, we depends on know-how. We depends on experience. If we didn't touch those design before, we need to depend on our intuition. Okay? We need to guess how to design. But even more sad is that, even more upset is that usually humankind's intuition is wrong. Okay? So we hope through education we can help the students to debug their own brains. Okay? To get rid of all those wrong intuition. Hopefully in the future, whenever they face new design, they can guess it correctly, hopefully. Okay, so you can see the learning curve for analog IC designers is much, much longer than digital IC design. Okay, even more longer than all the other fields. And this is the reason why IC design is the most difficult one. Okay, we Taiwanese select this way, not because it is easy, sorry for that. If it is easy, everybody can make it, right? It doesn't make any sense. So we need to select the hardest way. After we make it, very few people can compete with us. Okay, and so hopefully Indonesian will also select this way, but we can help. Okay, to the end, we can help, but I myself sincerely hope in the future, after you make it, you can help us. Okay, stand at our side. You don't need to fight for us, no. You just say, no, don't touch, good enough. America, Japanese, they will fight along with us, no worries. Yeah. Anyway, I'm not kidding. The most important issue is to get IC fabrication from our companies, hopefully. Okay? Yeah. So I will also teach my students the important IPs, cases, and common applications. We, humankind, never design something for nothing. Okay? If you design something without any real application, it's simply time wasting, right? To make money, we hope all those designs can be applied to many of the applications, many of the industry, just like mobile phone, cars, blah, blah, blah. It is good for the student, but also good for the country, okay? And then I only focus on operation principle, innovation, and what evolution we can expect in the future, okay? In brief, I don't teach my students the M.Sc equations, how to derive it. It's simply time wasting. Again, what you see is never be what you get. All those equations, I promise you, are totally wrong. I mean, according to practical measurement. Don't expect you can derive something to feed your measurement. No, sorry for that. It never happens in analog IC design. Okay? But why we still have so many equations? Simply because we need to understand the operation principles. So equations are only useful to help the students understand the operation principle. But sadly enough, most of the students, they get lost during derivations. Okay, so after they make it, I mean derive all those equations, they have no idea. Why? I have those equations. It doesn't make any sense. Okay, so I never derive anything in my class. It's simply time wasting for me and my students. Okay, I only explain, those equations, I explain the equations according to the operation principle. That is what I can help. All right, and then hopefully after my teaching, the student can live happily since after, make a lot of money. All my students after graduation, I mean, only from master degree. Okay? for the first year, they can make more money than myself in the past. Okay, yeah. Right now I'm above average in my university. Okay, yeah. Anyway, but yeah, after graduation, only a few years later, all of them can defeat me. That's it. Anyway, no equation derivation, no much detailed circuit or wrong generation. What does it mean? For some structure, it works here, just like a charm. But don't copy and paste it to the others. Sorry for that. Okay, unless you know what you are doing. Okay, for example, some circuit is really good for BJT, right? If you duplicate to most, sometimes it doesn't work at all. Okay, vice versa. So this is the reason why operation principle is the key. Okay, I hope all my students understand how the circuit works. It is really, really important, more important than equation derivation. Okay, that is some kind of content. I would like to bother you. And I need to be honest. I am a lazy professor. I'm too busy. So for most of my slides, I only get help from my friends or from international professors. Okay, I get help from them, and my promise is I won't use all those slides to make any money. No, only for education. Okay, that is my promise. I never violate it. So you can see, what is your dream? That is humankind. In the past, if you would like to construct something like pyramid, some kind of fantastic statue in your country, building, right? We need engineers. But how to calculate? To make it great, to make a huge building, you cannot do it by intuition. No. It doesn't make any sense. Okay? So we need some talented guys to calculate, but in the past, only by our own hands. It is really painful. Really, it took a lot of time. So from the very beginning, humankind had a dream to speed up such kind of scientific calculation. Okay, and this was the first computer. Okay, actually it is a mechanical one. So you can see, wow, many of the gears inside. After you input a key, type in, okay, the simple equation, then you press enter, and you can listen to after some minutes, I guess. Okay. Oh, the final will come out. That's it. It's a mechanical one. It is really heavy. Okay. It is money wasting. But it still opened the dream for humankind, because this is the first one. We don't need to do it by our own hands. It can help. Okay. But it opens a dream. What kind of dream? To make it smaller and faster. Okay, and such kind of dream is still going on now and even into the future. It never ended. Okay, it is everlasting. So more than 10 years later, you can see, we make it as an electronic one, ENIAC. Okay, it is totally electronic, no gears. But you can see, it is even bulkier. The volume is much larger than before, but the speed is faster. Okay? Why? Because we replace the gears, mechanical gears, with such kind of vacuum tubes. They can operate much faster than gears. Okay? So it opens another dream, because we already make it faster, but it's too bulky. We need to reduce the size. Okay? Allow me to show you this. The computation capability, I guess, is even worse than Casio calculator. Okay? Look into the future. What's our dream? This. quantum computation. Maybe. Okay? One atom can help us to calculate everything. Hopefully. Okay? So, to reduce the volume, the size, we need another device for help, transistor. So from the very beginning to the end, we focus on MOSFET, okay, and look into the future, FinFET. And after that, who knows? Okay? Yeah. Those three invented the first transistor. You can see it in Bell Lab or TI's lab, okay? Yeah, it is still there. You can go there to worship because it opens a new dream, a new era for all humankind. With transistor, we don't need vacuum tubes. Okay? Then, to my memory, maybe, this is, they got Nobel Prize, yeah, in 1973. Around 10 years or something after the invention. Okay, but allow me to show you another one sad but even more inspiring story. That is the magic Jack. Jack Kilby, yeah, created the first IC. What does it mean? Integrated circuit. Okay, and what is the definition? He would like to integrate more than one device, more than one transistor on the same substrate. In the past, one transistor, each substrate could only be used to fabricate one transistor. And this young Jack, he told his boss, I had a dream to integrate more than one. His boss said, okay, it is interesting. Huh? And then, nothing, right? So, young Jack was not satisfied. Why? My boss wouldn't like to listen to me. So, in one weekend, all his colleagues went out for drinking, touring, to enjoy their lives. Young Jack stayed in the lab to fabricate his own dream, and he made it. This one is still, in, I guess, TI. Okay? Yeah, you can see it. It's still there. So when the young guy made it, 1958, and when, according to his idea, it changed the life of humankind totally, right? Your country would like to develop semiconductor, blah, blah, blah. Focus on chips, integrated circuit, and he is the king. He is the creator. He changed humans' life even more, even further than those three guys. But unluckily enough, sadly enough, he got Nobel Prize in 2000. Wow. What lesson, young guys, you learn from Magic Jack? Huh? After how many years? 42. So, what lesson you guys learn from Jack? You need to live long enough to be awarded. So it means what? It means what? You need to balance your work and life. Okay? Don't focus so much on your work and put your own health in risk. Otherwise, you won't be awarded. You won't get rewarded. Sorry for that, okay? Yeah. Anyway, after the first integrated circuit, humankind got many kind of the different type of transistors, but to the end, CMOS dominate the overall industry, and this is what we can make in the past. Okay, after young Jack made it in 1958, 3 years later, the first commercial chip was launched to the market. Okay, and how complicated the first IC is. Really interesting. It only consisted of dual flip-flop with only 4 transistors. It's simple to test, but please have a look. The cost, $50. My gosh! According to the valuation, right? Each chip maybe equivalently today tens or tens thousands, at least thousands of US dollars. Wow! For only 4 transistors, right? So it opens a dream for money making, right? But that is the first, and you can see 2 years later, from the same company, Fairchild, the second generation consists of 4 flip-flops. It means 8 transistors. Okay, the number of transistors was doubled, but you can see the chip size is reduced. It is another everlasting dream for humankind. We would like to make it faster, more complicated, better performance, but with smaller size. This dream is never ended. And Indonesia would like to join. Welcome to Semiconductor, to join such kind of everlasting dream for all humankind, for all countries on earth. Okay, so you can see from Intel, right? Yeah, years later, Intel announced the first, how can I say CPU? Maybe MPU or something, a very simple version. In 1971, the microprocessor called 4004, actually it composed already 1,000. Okay, look, from here to there, only 8 years later, the number of transistors was already not double, not triple, no. More than 100 times increased. Okay? And then you can see, years later, it's already 42 million. Gosh. Okay? But another joke is, after the success of Intel, it means something because integrated electronics, okay, combine both to be Intel. So many of the other companies, they would like to copy and paste such kind of creative ideas, so they have out of the market. Okay, yeah, and maybe we have Microsoft, right? So you can open a company called Microhard. It's really hard to survive. Okay, and anyway, Microsoft even worse. Anyhow, to make it successful, it doesn't depend on the name. Okay, it depends on the worker, on the founder for creation, innovation, and most of all, business model. It doesn't depend on such kind of silly names. Sorry for that. So Indonesian would like to be successful in this field. Okay, yeah, don't open any companies just like this. Okay, all out of the market. All right, and then allow me to show you some more recent progress. 5 years ago, that is A12, and you can see it is designed in TSMC 7nm process, and you can see, almost 7 billions, okay, about the same number of the whole population. But it's already 5 years ago, so let's go further. See, 2 years later, or 3 years ago, you can see Apple M1. How much? 16 millions. Okay, is it the largest chip in that era? No. Allow me to show you. Yeah, Xilinx. 2 years before, it already made it as 50 millions. Okay, but as the top one semiconductor company, IC design house on earth, Apple would like to fight back. So allow me to show you the most updated information. Apple M2 Ultra. Okay, Ultra means what? To my memory, 2 N2 chips. Yeah, folded, attached to each other. Okay, then you can see designed in TSMC 5 nanometer process. So for M3, I guess 3 nanometer. I guess. Okay. Anyway, let's go to have a look. Wow, it's already twice as much as total human population. 130 something billions. Is it the biggest chip on Earth? Of course not. Of course not. Allow me to show you. Even worse is this. It is called what? Wafer scale chip. Okay? It means the chip is made of the whole wafer. The wafer is a cylinder. It's a circle, right? So you cut 4 edges, and in the middle, congratulations, that is a single chip. Wow, gosh. So how much? It's already 2.5 trillions. Not now, sorry. It is, when? Maybe 2 or 3 years ago, okay? Anyway, you can Google it. Because you can see, it is made in TSMC 7 nanometer process. And the newest version is in 5 nanometer. Okay, this is the second generation. And the next, I guess, maybe more than 10 trillions. Okay, wow. That is our dream. We, humankind, are greedy for performance. We would like to defeat all the others. Okay? So you can see NVIDIA A100, that is some kind of hot potato. No. Yeah. Hot chips on Earth. Chinese company would like to buy it with maybe more than 10 times regular price anyway. Okay? But compared to this one, okay, Cellular, they can make it even further. So it is not allowed to sell such chips to China. No, of course not. Of course not. Okay. In this way, we hope the gap between China and democratic countries will be further enlarged. That is for our goodness, maybe also yours, because China is already in front of your door, right? Some of the island, you have trouble with China because China claims, this sea is called South China Sea. China focus on this. So everything inside this sea is ours. Are you happy? If not, please stand beside. Don't release this. Don't release it online. Otherwise, someday I will be kidnapped by Chinese back to their own bad country. Okay, that is the very beginning for our overall semiconductor industry. Moore's law. You can see who is Moore, Gordon Moore. Actually, he's only one of the co-founders of Intel. And what does he do? He made any kind of brilliant chip, just like M2 Ultra, just like the wafer scale chip. No. Nobody knows what's his achievement, but everybody knows Moore's law. Okay? Only after 4 years of watching, you can see the first commercial chip was announced in 1961. Right? 4 years later, Gordon Moore put some kind of prediction for all humankind. Every 1.2 to 2 years, the number of transistors on chip will be doubled. That's it. Okay, that is why Gordon Moore is more famous than all the others. Okay? Well, It's amazing. What lesson you guys learn from this? Huh? You need to, if you cannot do anything fantastic, if you cannot design anything fantastic, and you can go for this way to say something very important. Okay? Anyway, anyhow, he's one of the co-founders.
Okay, then you have 15 more minutes.
Okay. I will finish very soon. Okay. Anyway, anyhow, it's almost. I can do. Yeah. Anyway, it is one of the co-founders of Intel. So who helped Gordon Moore to keep his promise? Yeah, to realize his prediction. Intel, but years ago, Intel simply could not. Okay, so what else helped? TSMC. Till now, it is still TSMC to help Gordon Moore to keep his promise to all humankind. Okay? Anyway, anyhow, sadly enough, Gordon Moore passed away in this year. But Moore's law is still alive. Okay? It's really, really important. Do join us. Yeah, anyway, anyhow, so hopefully, let me check. Oh, from the very beginning, I told you guys already, I'm really talkative. Sorry for that. Even why I went to bed in early morning, I mean at 1 a.m. Because I'm still revising the slides for you. Okay, but I didn't show the most updated information. Sorry for that. So anyhow, let me check. Oh, this is an important prediction. We are here now. Okay, TSMC FinFET for 3 nanometers, and for Samsung actually it has some kind of flag lip. Yeah. Oh, more advanced than TSMC. It implements such kind of GAA, gate all around, right? So in theory, this Samsung GAA in the same 3 nanometers is supposed to be better than TSMC 3 nanometer FinFET, but actually it's not. No company went to Samsung for fabrication help. That's it, finished, it's done. Okay, yeah, anyway, go to the end, you can Google online iMac. That is the prediction of iMac. Okay, yeah, anyway, you can see according to, yeah, all those big elephants fight with each other, right? Who will win? Let's have a look. Such kind of equipment vendors on Earth. The top one, Applied Material. From which country? USA. Okay? Lam Research, to my memory, from UK. Okay? And then ASML from Netherlands. Okay? And then Tokyo from Japan. Luckily enough, all those from Americans allies. I mean, from democratic countries. Hopefully, in this way, we can contain China and Russia very much to limit their capability for more advanced weapons. Yeah. So if they do anything bad to the world, maybe we can defeat them, put them back to Stone Age, hopefully. Don't put this online, okay? We are friends, we are not enemies, okay? Yeah, anyway, that is not, it is not only happened for such kind of equipment, for EDA tools, all top 3 from America, okay? So, all in all, we democratic countries still have a hope. Okay, we can defeat all those bad countries. So, since I have, the time is quite limited, allow me to show you some, not here. To inspire you more to join us, to join the semiconductor industry, allow me to play some, okay. Yeah, I asked my student to prepare the videos. Eh? Not here. So, here? Okay. Pranata. All right. He's from ITB. Oh, yeah.
Of semiconductor industry in the world. There are a lot of electronics companies that are so well known in the world, actually founded in Taiwan. And you as a foreigner also have equal opportunity to work in those companies. Yeah, I wish I knew about this program back then when I was still a student. This is actually a very good opportunity for you to experience the education system in Taiwan and also life in Taiwan. In this way, you can have a better understanding about the career path that you want to pursue. I encourage students to come to Taiwan to pursue a higher degree of education. As an engineer, I recommend NTST as your destination because it has a lot of good professors and also facilities to support your study and your research. So that after you graduate, you can work as international talent in Taiwan or go back to your home country to develop your country. So are you ready to be the next international talent in Taiwan?
This is some kind of demo. One of the ITB students studied in my lab after getting the master degree. He worked for one IC design house, and in last August, he transferred to TSMC. So I guess, because he worked already for maybe 5 or 6 years, I guess he made already $100,000 per year. Okay? Yeah. So, why not you? Don't teach here. No. Oh, no. I enjoy, as a professor, I enjoy my life very much. Nothing is free. I pay my money for freedom. Okay? Actually, my son only get a bachelor degree, but he works for Google. Yeah. His salary is already higher than myself. It's really upset. Okay, finally, I think I can have UI. Yeah, one student from UI for TEEP. Okay, for TEEP promotion.
Hello, I'm Fatih Ghazi Zulfikar. Here I want to tell you about the Taiwan Education and Experience Program. I'm an Indonesian undergraduate student from the Department of Electrical Engineering, University of Indonesia. And in the middle of my undergraduate studies, I decided to join the TEEP program because I thought this program is great for students like me to open my horizons, open my eyes to world of standards of knowledge. Taiwan's Ministry of Education launched the Taiwan Experience and Education Program, or TEEP, to encourage more international students to participate in short-term professional internship projects. All TEP programs are provided and guided by Taiwan Ministry of Education and most commonly with laws and regulation to ensure the education quality. Also, in Taiwan is very friendly and convenient. Taiwanese people are among the most friendly in the world. Taiwan has world-class semiconductor manufacturers such as the world's largest IC company like TSMC or UMC, and college campuses in Taiwan that encourage students to learn before entering the industrial stage. NTUST is one of the campuses that has developed in field of integrated circuit, and here we are, AIC Lab or Analog Integrated Circuit Laboratory, Department of Electronic and Computer Engineering, National Taiwan University of Science and Technology. Here with Professor Poki as the laboratory's professor with the purpose of the establishment of the Research Institute's Design Laboratory. This lab provides integrated circuit design research of analog and also digital mixed signals that focus on the time signal processing IC design. In this internship, I had the opportunity to study about field programmable gate array or FPGA. It's a type of integrated circuit that can be configured after manufacturing to perform specific functions, making it highly flexible and customizable for various applications. Learning FPGA programming, especially for sensor applications, offers many advantages. The integration of multiple sensor interfaces, data pre-processing and decision-making logic simplifies system design and reduce relation of external components. Now I am very grateful to have opportunity to join the TEP program. This program provides me a hands-on opportunity to apply theoretical knowledge gained from academic studies to real research projects. This practical experience helps me for understanding, enhancing my skills, bridging the gap between the theory and application, also collaborating with experienced researchers, professors in the laboratory environment. Also, networking with professionals in this field can also open doors for future collaborations. And I was also able to do some refreshing, of course, offside of my research activities by visiting some various places in Taiwan. Yeah, I'm waiting for you here, so that's all from me. Thank you. See you again.
All right, I'm done.
Okay, please do.
Terima kasih.
Thank you very much, Prof. Poki. Is there any question from this interesting topic, please? Yeah, 1, 2. Okay, this first one.
Yeah, okay. My name is Alvin. I'm from electrical engineering master's degree. I would like to know if there is any opportunity for us to join some kind of double degree program, if there's any, and maybe if there's any also full scholarship or something like that. Yeah, thank you.
Oh, okay. For your first question, yes, of course. Your head and you are the body or tail. Anyway, told me yesterday you sent a few students to my university for dual master degree program. So it is totally possible. But how to make it? You can contact your department. Okay. And for the second years, we provide full or partial scholarship, but it's really unlucky that since this semester, the stipend from the supervisors is tripled. Okay, it is not doubled, it's tripled. So I need to sponsor my new international student $200 US each per month. Is a heavy burden. Yeah, right now I can show you. I have totally 5. Okay, how can I survive? It's mission impossible. So unless your GPA is really good, you can get Taiwanese scholarship or partially sponsored by TEEP or by Indonesian government. Otherwise, I already told my student, Crystal, he's from UGM. He may be the last international student I would like to recruit, because if I need to spend so much money for my international students, how about my local ones? Okay, they already complained very much. Yeah, but I told them they had better treat my international students well, because in the future, many of them will stay in Taiwan, work hard, so they are our friends instead of our enemies. Okay, but according to the new regulation from NTST, I'm afraid I need to tell you something already goes really wrong at our side. Okay?
Okay. Next.
Test. Beforehand, I would like to thank Prof. Poki Chen for coming to our university. So my name is Muhammad Kafin Gantara, and I am an ethical engineering undergraduate from the 2020 batch. I would like to ask a question regarding the semiconductor industry. As we know, currently there is a trade war in the semiconductor industry between the two economic superpowers, the US and China, and it doesn't help that the facts that the Biden administration curbed notable semiconductor companies like SML, TSMC, Kaohsiung, Stocker Electron, among many others, from selling their advanced products to China, like the latest EV machine and lasers with high numerical aperture. The slowing growth of the smartphone market share, the demand of semiconductor talents exceed the supply, and the present soaring inflation, thus making it harder and much more effective to develop advanced fabrication process in sub 5 nanometer, and also indicating a partial decoupling in the semiconductor industry. On the other hand, act like the creating helpful incentive to produce semiconductor or Chip X, and European Chip X give incentive and benefits for companies like TSMC, GlobalFoundries, and Samsung for building fabrication sites in the US and Europe soil. And there are also the promises of the quantum technology. Both of them directly bolstering the global semiconductor development. Based on this international and multilateral event and situation, what vision do you have about the future of the global semiconductor industry in the next 3 to 5 years?
Oh, you have very long and also hard question, but I can answer in an easy way. Briefly speaking, I think I highlight the pros and cons according to the American, Chinese, the so-called trade war. I strongly believe that we work together so we can make it better. But for China or Russia, they only work by themselves. I don't think in the long run they can compete with us. And TSMC, Intel, GlobalFoundries, all of us, along with the EDA company, all top 3 in America, okay? And the fabrication equipment company, testing, packaging, everything, mechanical, semiconductor mechanical. All those key material, key tools, the top ones are still in Western, democratic countries. So I guess nothing will go so wrong for Americans' democratic allies. Okay, yeah, I guess, because America till now is still the top one for talented guys to migrate. Okay, and how many would like to migrate to China? Are you? Yeah. What is life? Right? You can, at least here, you can say no. Okay? If you go to China and say no, you will be put into the jail and disappeared from the earth. It doesn't make any sense. Yeah. So even China tried to offer me some kind of sweet deals. Even weeks ago, they tried to contact me. Anyway, but to me, it doesn't make any sense. I think for most of the humankind, money, if it is enough, it means enough. Okay, we don't need to make much more because we still need to focus on our life, our free style of living. Yeah. Anyway, anyhow, that is my easy answer to your question. Hopefully. Okay.
Okay. Okay. Because we have a Friday Solar, I think is it enough if there is any question about the like TEEP program or double degree program or fully program, you can ask to the Department of Electrical Engineering because we have the website and also the graduated student. You can ask about that. Okay. Thank you very much again for Prof. Poki Chen. Please give big applause. I will give back to them.
Thank you. Terima kasih.
Okay, thank you very much, Professor Poki and Mr. Tomy. And please, Prof. Poki, to stay on the stage. And we invite Dr. Arif to give a plaque and souvenir to Professor Poki.
Oh, you are really kind. Actually, it's, even though it is unnecessary, but I'm much honored. Thank you.
Okay, and we also have souvenir. Okay, and now there is a photo group session with all participants, and please to all participants can take position, maybe in center. Okay, please.